The subject of an inclined plane with a card on it and firing off a projectile perpendicular to the surface came up. So I put together this spreadsheet like I often do, but like many of my spreadsheets is a little overwhelming at first. What it allows you to do is it allows you to change anything that's in yellow. Anything that's not yellow you can't change. So you can change the incline, you can change the initial velocity of the cart, of the projectile, the direction of the projectile when it leaves. And if you really wanted to, you could change G, the masses. Doesn't really matter that much. Now, every other reference frame is just shifted or rotated by some number of degrees. So if you look at the direction, you can quickly see, oh wait, this is shifted by 30 degrees because the incline is 30. But I also gave you the ability to make it any angle that you want. I want to show you that you can change all of these in yellow with the slider, which is useful. And I calculated various things like the force, and from the force we get the acceleration, and from the acceleration we can get the equations of motion and get the time in the air and all that stuff. But one thing that people may not realize you can even do with a spreadsheet, most people probably realize you can graph X versus Y, but what you may not realize is you can actually hide certain data points if you want. So what I've done is I put in a slider here that will allow you to only show the part of the data you wish to see. So this is the percentage of the whole path that's being shown. So in that way, it's sort of, it's just Excel, but it's sort of like a simulation where you can do that. It does run better on the old Excel. I'm not sure why it runs slower here, but I think you get the idea. And you can see that it looks very different depending on your frame of reference. From the inclined plane, you can see that it's horizontal for the cart. And the other thing that's kind of interesting here is instead of the parabola we're used to seeing with quote-unquote regular projectile motion, here you can see clearly there's a horizontal component of acceleration. That's the component down the ramp. Just for fun, I also put here, so as you step through, you can see the velocities at any point in time and see how they change. It's also kind of fun to see what happens when you change the, let me put this all the way, when you change this third reference frame, this other, and you can do that using the slider at the top or down here, and you can see quickly it changes quite a bit. And you would expect at 0 degrees and at 360 degrees you would get the same thing as over here at the grounds reference frame. So basically I thought this was a fun way to investigate the problem, and I hope that somebody somewhere finds it useful.